Okay, how are you guys? This is Mr. Trutna, Clovis High School Cougars. This is Math 1, and we're going to be going over Worksheet 6.4b. Okay, and this is what the worksheet looks like right here. Now, notice the instructions when we're looking at it. It says, use a graphing utility to find the linear regression equation for the given data. Okay, so my graphing utility is going to be nothing fancy when I'm doing this. What I'm going to be doing is I'm actually going to be using a piece of graph paper. Okay, so number one, we have a student who waits on tables at a restaurant, recorded the cost of meals and the tip left by single dinners. Okay, so this says if the next diner, that's diner, it should say dinner, orders a meal costing $10.50, how much tips should the waiter expect to receive? So what we're going to do is we are going to create, and we need to come up with an equation. We're going to use that equation then to figure out how much tip $10.50 meal, a costing of meal, would give us. Okay, so what we do is we are going to take out a piece of graph paper, and we are going to create a scatter plot with our data that we have here. Okay, so remember that when we make a scatter plot, we draw a vertical line, then we draw a horizontal line, okay, and then typically whatever the first row of information's about, which is meal cost, that is going to be what our horizontal axis is going to be titled. And then whatever the second row, which in this case is tip, that's going to be what our vertical axis is going to be titled. And then what we do is we make intervals. Okay, and our intervals are, we use whatever information we need to help us make our intervals. So you can see my meal cost is going from $4.75 up to $6, $12, $20. So I have to go pretty much all the way up to $20. So what maybe I could do is, if I went by, say, dollars, okay, if each interval was $1, then that could give me my meal cost. So if I went 1, 2, 3, 4, 5, 6, 7, 8, 9, so on. Okay, but I gotta go all the way up to 20. So I'm gonna make every interval worth $2. Okay, so 2, 4, 6, 8, that'd be $10, $12, $14, $16, $18, $20, and I have to go up to 22. I have to go a little bit past 20. Okay, then for my tip, you can see my largest tip is $3. So I think if I made every other the interval $1 tip, so that would be $1. So this is 50 cents right here. Okay, so that would be $1.50. This interval here would be $2. Then we would have $3. Then we would have $4. And of course, halfway in between, that'd be like $3.50. My largest tip is going up to $3. Then I'm going to use these points right here to create like a scatter plot. Okay, so I have $4.75, which is, I'm going to estimate, is about right there. And then I go up to 50 cents. So I put a point there. Okay, when I have $6.84, that's going to be almost halfway, because halfway would be 7. I go up 90 cents, which is just a little bit below $1 tip. All right, then when I have a meal that costs $12.50, maybe about right there, I go up, I get a tip of $1.50, which would be right there. Okay, and then when I have a meal that costs $20.42, maybe about right there, I have a tip of $3. Okay, I put a point. And lastly, when I have a meal that costs almost $9, $8.97, that'd be almost halfway between 8 and 10, I have a tip of $1. So you can see what we have here, we get a scatter plot. Now we use that scatter plot in order to figure out our equation. Once again, we're trying to write an equation, okay, of the information. So I need to come up with a line of best fit. So remember, a line of best fit is going to be a line that goes through at least 2 points and then I should have the same number of points below and above the line. So I would say this line right here is a relatively accurate line of best fit. You can see I've got a minimum of, I have at least 2 points on the line, okay, and then I got 2 points above the line and 1 point below the line. Maybe I could have angled it a little bit more, but we're going to go with that. Okay, so I need to write an equation of this line of best fit. So in order to write the equation, there are two things that I'm going to have to do. The first thing that I'm going to have to do to write the equation is I'm going to find the slope. Okay, well, the slope, I'm going to use the slope formula. y2 minus y1 over x2 minus x1. Okay, and I'm going to use my 2 points on the line. So this point right here, its coordinates are going to be 8.97 comma 1, and then this point's coordinates are going to be, what was it, 20.42 comma $3. So 20.42 comma 3. Okay, so plugging in these values, my y2 value is going to be 3 right here, minus my y1 value is going to be 1, and then I'm going to have that over my x2 value is going to be 20.42 minus my x1 value is going to be 8.97. Okay, and then what I do is I get a calculator and I calculate the slope. So I'm walking to the back of the class right now. I'm grabbing my calculator off my desk, and I'm going to calculate the slope of this line here. Okay, so 3 minus 1, well, that's 2. 20.42 take away 8.97 gives me 11.45, and then 2 divided by 11.45 gives me a slope of 0, and I'm not going to write that entire decimal down, but I'm going to write 0.17. So that's my slope. That's my m value. Remember, m means slope. So when I'm writing an equation from a line of best fit, I find the slope. Then the second part that I do is I'm going to use the point slope form of an equation, y minus y1 equals m, then parentheses, x minus x1. Okay, and remember when we're using this formula to create an equation, I put a number value in the place of y1, in the place of m, and in the place of x1, and then I leave everything else as is. So y stays y, y1 I said was 1, equals my m, which is my slope, is 0.17, and then I go parentheses, x stays x, minus stays minus, and x1 I said was 8.97. So that is going to be my equation. Now I'm just going to simplify this. So when I simplify it, I distribute the 0.17 into both of these values inside the parentheses. That gives me 0.17x minus, and then 0.17 multiplied by 8.97 turns out to be 1 point, and I'm just going to say 1.52. Okay, so this becomes 1.52, and then I add 1 to both sides because I want to get my final equation in y equals mx plus b form, and I get y equals 0.17x, and then we have negative 1.52. I have to treat that as a negative there, so I'm going to go negative 1.52, trying to find my negative function on my calculator right there, negative 1.52, and then I add 1 to that, and that's going to give me negative 0.52. So this is my equation of my line of best fit. Okay, so where this problem says write the equation, I'm going to write it right there. So I get y equals 0.17x minus 0.52. Okay, now what does x represent? Well, x represents my meal cost. What does y represent? Y represents my y-axis, which would be my tip. Okay, so then the question is, if the next dinner orders a meal costing $10.50, how much tip should the waiter expect to receive? So what we do is we take this equation, y equals, we have 0.17, and what we're going to do is, instead, in the place of x, we're going to substitute the $10.50. So 10.50 minus 0.52. And I work this out, and remember y is going to be what my tip is that I expect. Okay, so computing this, I get 0.17. I multiply it by 10.50. That gives me that 1.78, and then I go minus 0.52, and there's my answer, 1.2, and I could round that to 27. So my tip to be expected would be $1.27. Okay, so that's the process that we're going to use in order to do these problems here. All right, so number 2, the table below gives the number of hours spent studying for a science exam and the final exam grade. All right, so I have all of these values here. I'm going to predict the exam grade of a student who studied for 6 hours. Okay, so I need to come up with an equation. Well, how do I get an equation? What I have to do is, once again, I have to create a scatter plot for this information. Okay, so to create a scatter plot, I draw a y-axis, and then I draw an x-axis. Okay, so then I label what does each axis represent. Okay, well, each axis represents, my x-axis is going to be the science exam. It's going to be the hours spent studying. So this would be hours studying. And then my y-axis is going to be my final exam grade. Okay, so we'll just put grade here. So that's going to be my final exam grade. Okay, and then I'm going to make intervals. How do I want to set up my intervals for me so then I can plot my points and make my scatter plot? So my hours studying, the highest was 5. So I think it's pretty good. I'll just go, that'd be 1, that'd be 2, that'd be 3, that'd be 4, that'd be 5 hours spent studying. Okay, my final grade, you could see my highest grade is a 92. So obviously I don't want to set up intervals of 1. So what I'm going to do is I'll go ahead and set up intervals of, let's see, if that was 10, 20, 30, I don't want to do that. Let's go by tens. Okay, wait, so I don't even know if I'll have enough room. 10, 20, 30, that'd be 40, 50, 60, 70, I don't have enough room. So we'll make every one 10. So that'd be 10, 20%, 30%, 40%, 50%, 60, and so on, okay? And I'm going to go all the way up, I'll carry it all the way up to 100%. Okay, and then what I do is I'm now going to plot points. So when x is 2, y is 77, so I go up to about where 77 is when x is 2, about there. Plotting points, each one of these represents a point. So then I go 5, and then I go to 92, and I'm estimating where 92 is. Okay, when you spent 1 hour studying, that person got a 70%. When you didn't study at all, that person got a 63%. 4 hours of studying, that person got a 90. Good for that person. They studied smart. 2 hours of studying got that person a 75%. All right, which is just slightly below 76. And then 3 hours of studying got that person an 84. So you can see I have a scatter plot here. So I'm going to write an equation of this scatter plot. Okay, in order to write an equation, I need to have a line of best fit. So I'm going to try to, you can see I could get a lot of dots on one line here. I could get all of these dots right here on the line. Okay, so now I need to write an equation of this line. So what do I do to write an equation of the line? Okay, so there's 2 things I have to find. And I find the 2 things in order. The first part that I want to find is I want to find my slope. So once again, to find the slope, I use the slope formula. Now, in order to use the slope formula, I have to identify 2 points. All right, well, I've got a point right here. That is 1. Its coordinates are 1 and 70. And then I've got another point right there. That point's coordinates are 2 and, what was it, 2 and 77. Okay, so I'm going to use these points to find my slope. Okay, so plugging in those numbers, y2 is going to be 77 minus y1 is going to be 70. That's going to be over x2 is going to be 2 minus x1, which is going to be 1. Okay, 77 minus 70 is 7. 2 minus 1 is 1. So that means my slope is going to be 7. Okay, then the second part that I do, and I have to do these in order, is I write down my formula for point slope, which is y minus y1 equals m times the quantity x minus x1, and then once again I'm going to plug in numerical values in the place of y1, m, and x1. Everything else I'm going to leave as is, and then I'm going to simplify it to get my equation. So this will become y minus y1, we said was 70, equals m is slope, that's 7, parentheses x minus x1 we said was 1. Then I just simplify this equation. So I distribute the 7 into both things in the parentheses. That makes my equation y minus 70 equals 7x minus 7. I add 70 to both sides. I'm going to get this equation in the y equals mx plus b form. And when I do that, I get y equals 7x plus 63. So that's going to be my equation that I'm going to use. Okay, y equals 7x plus 63. Now I'm going to use that equation to answer my question to get the grade that I expect. Okay, this says predict the exam grade of a student who studied for 6 hours. Okay, so I'm going to take my equation right here. Y equals 7, but now x is, remember x stands for however many hours we studied, so we're going to turn x into 6 plus 63. That's going to be 42 plus 63. We're going to get y is equal to 105. So my grade that I would expect this person to get would be 105. Okay, so that's how we would go about doing number 2. Let's do one more, and then what I'll do is I'll just post the answers to numbers 4 and numbers 5, okay, for the rest of it. Okay, so in this one, it says the table below shows the lengths and corresponding ideal weights of sand sharks. Okay, it says predict the weight of a sand shark whose length is 75 inches. All right, so what we're going to do is we're going to make a scatter plot of all of these points. Okay, so to make a scatter plot, I draw a vertical line. The vertical line is going to be the information about the second row of data. I draw a horizontal line. The horizontal line is going to be the information that is about the first row of data. So this is going to be length. This axis, which is the y-axis, that's going to be weight. And then I'm going to make my intervals. Okay, so you can see my length. I have to go up to 72. So I'm just going to go by 10s. So that would be a length of 10 inches, 20, that would be 30 inches, 40 inches, 50 inches, 60 inches, 70 inches, and I should go probably up to 80. And you could fill in each value, or you could skip ones like I'm doing, okay? Then for my weight, you can see my maximum weight is going to be 158, so I have to figure out how do I want to scale my weight, okay? I got to go all the way up to 158, so going by 10s might not be the best way to go. So what I might want to do is, let's go ahead and let's go by 20s. So that would be 20, 40 pounds, 60 pounds, 80 pounds, 100, that'd be 120, that'd be 140 pounds. Once again, I got to go up to 158, so I'll stop at 160 pounds. Then I'm going to use each one of these pieces of data in order to get my scatter plot. Then I'm going to use my scatter plot to create an equation. Okay, so when I have a 60-inch long sand shark, it weighs 105 pounds. So 105. And I'm just estimating where they are. Okay, when I have a 62-inch long sand shark, it weighs 114 pounds. So maybe about right there. All right, when I have a 64-inch long sand shark, it weighs 124 pounds. So maybe about right there. When I have a 66-inch long sand shark, it's up to 131 pounds. When I have a 68-inch long sand shark, that weighs 139 pounds. So about right there. These are very close together. When I have a 70-inch long sand shark, it weighs 149 pounds. So that'd probably be about right there, because 150 is halfway. And a 72-inch long sand shark is going to weigh me almost 160 pounds. So this is my scatter plot. Okay, so I'm going to try to, obviously this does not have perfect correlation. I can't put all the points on the same line, but you can see I could get quite a number of points on the line. So when I draw my line of best fit, you can see I got one kind of below it, one kind of above it, then I got a bunch of points on this. Okay, so now I'm going to use this line to write my equation for my line of best fit. Okay, so how do I do that? Well, the first thing, once again, to write the equation, I have to do this in order. I find the slope. So I'm going to use the slope formula, which I'm writing down here again. y2 minus y1 divided by x2 minus x1. And then I need to identify 2 points. I'm going to identify this point right here, which was 60, 105. And then I'll go ahead and I'll identify this point right here, which would be my last point, which was 72 and 158. All right, so those are the 2 points that I'm going to use. Putting these in the formula, my y2 is going to be 158 minus my y1 value is going to be 105. Then I'm going to divide that by my x2, which is 72. Minus my x1 value, which is going to be 60. 158 minus 105 is 53. 72 minus 60 is 12. And then I divide that out. So 53 divided by 12 is going to give me my slope. 53 divided by 12 gives me 4.41. All right, so I know that my slope is 4.41. So that's the first thing I find. Then the second part that I do to find my equation is I put in the information into my point slope equation of a line. Okay, there's my point slope equation of a line. Once again, you're going to put numerical values in the place of y1, m, and x1, and everything else you're going to leave exactly as they are. Okay, so doing that, I have y, I have a subtraction symbol, y1 I said was 105. That's equal to, m we just found out was 4.41. Then we're going to go parentheses, I put an x, I put a subtraction symbol, and then x1 we said was 60. Okay, now I'm just going to simplify this equation. So I'm going to distribute the 4.41 times the x and times the 60. That'll give me y minus 105 is equal to 4.41x minus, and then I got to go 4.41 multiplied by 60. So that gives me 264.6. And then I add 105 to both sides. I'm going to get this equation in the slope-intercept form. Okay, when I do that, I get y equals, those 105s cancel out, 4.41x, and then I'm going to go negative 264.6 plus 105. That is negative 159.6, so minus 159.6. Okay, that's my equation that I'm going to use in order to estimate my question. So my equation is y is equal to 4.41x minus 159.6. And now the question is, predict the weight of a sand shark whose length is 75 inches. So how much would a 75-inch land shark weigh? Well, what I do is I take my equation, y equals 4.41, but in the place of x, I substitute 75 because length was my x value, minus 159.6, and I compute this out to get my expected weight. Notice it says round to the nearest whole number, so that means I'm probably going to get a decimal for an answer, so 4.41 times 75, then I'm going to go minus 159.6, and I get 171.15. Rounding that, I'm going to estimate it to be 171 pounds. All right, so there you go. Do number 4 and 5 on your own. Check back later to see what the answers are.